Hi everyone! So I'm making a video. I'm going to start doing these. I forgot how much I love making videos. They're so much fun. So today we worked on proportions in similar right triangles. I know how hard it was. I know it was complicated and you guys are frustrated and mad and still one of those. Like your brain is just exploding with a lot of information. Now, we got this. You got this. You're smart. I'm sorry about my voice. I think I'm losing it. And I'm watching The Voice and I need to know who this kid is going to pick. So we're going to do math and figure out The Voice at the same time. Yay! So if you don't believe me, there's The Voice right there. That's the kid who was singing. Now let's do some math up in here. So on my computer, yeah, fancy Mac. These are our two theorems. Now, we were dealing with triangles that looked exactly like this. So let me draw it. We all know I am the best drawer up in here. Now remember, CD is my altitude in this triangle. We're going to pretend these are all right angles. And X. Now, the first one is altitude rule. The altitude rule basically says if they're asking us to solve for our altitude, which is here, my CD, you just make sure, oh, the guy got Team Blake, holla, that your altitude is on opposite sides. So your altitude. Then from there, we're going to do line AD goes with line DB. That's all it means to be the altitude rule. Nothing complicated, nothing fancy. I think you guys can handle the non-fanciness. So that is one rule. Now let's erase. Now, the other rule is if they give you a leg. Now, that means if they're giving us, we're going to semi-erase this. Wish I had like a lot more markers. Is if they're giving us any line in here that does not have the hypotenuse. Now, if they're giving us, say, line, computer, wake up, CB, because CB is technically a leg. It might not be a leg in this tiny triangle, but it's a leg in the big triangle. So again, we want CB, so they have to be on opposite sides of each other, otherwise our answer will not come out correctly. Then from there, this leg, that means we're going to use this line. And then AB. So we're doing the big triangle. The hypotenuse to the leg of the big triangle goes with the hypotenuse to the leg of the small triangle. That's all this is saying, guys. We just need to look at what we're getting and what we're using to solve for these equations. They're not rocket science. I know they seem like it's rocket science up in here. It's not really rocket science. It's a bunch of math people trying to make you think it is rocket science up in here. Now, we are going to solve two problems right now because use the smarty pants. It was okay? It was okay. So, we got my beautiful triangle. We got A, C, B, a right angle, a D, right angle, right angle. So, so this is the first theorem I talked about, the one where they're giving us the altitude. So my altitude is going to be X. From A to D is 16, and from D to B is 4. I need to find what X is. So exactly what we did. And our altitude, two things. X, X, X. Let's put those first. 16, 4. X squared, now cross multiply, X squared is equal to 64. x is equal to 8. So our length of our altitude line CD is equal to 8. Voila. Right? So that is when we're using just plain old altitude. Now, if I am using the leg, let me erase this, make it all beautiful so we could do some more math. Everyone loves math. I don't understand people who say they don't like math. It makes me cry on the inside. Cry. Now, for this one, it is saying my length of CB is x. Here's 2, and this whole length is 8. This is the second one that we talked about. So here is my leg. Line CB is a leg. So again, they have to go opposite of each other. So x, x. So this leg in this triangle. So let's look at my bigger one. Here's my big triangle. This leg goes with the whole hypotenuse, which is 8. But now if I look at my tiny triangle, the leg here is 2, and my hypotenuse is x. Alright, I hope you guys... That's all it is. Now we have x squared is equal to 16. X is equal to 4. So the line of CB is equal to 4. Alright guys, you cannot freak out about this. These are not hard. It's just looking at what we have and manipulating it. You want to use what we have and figure out what two triangles have the same side. Like how the first one, the two smaller triangles had side CD, so we didn't use our larger triangle line, triangle ACB. Now on our second one, we had side CB. We used our big triangle, triangle ACB, and one of our small triangles, triangle CDB, because those two had the same line in it. You guys are going to get this, I promise. I'll see you tomorrow morning. Hopefully I have a voice. Bye.